So this video is on the laws of exponents, okay, and fractional exponents. So first, just to kind of go over the laws of exponents, if I have x to a power times x to a power, you add the powers. So we see x to the fifth times x to the sixth, you add and you get x to the 11th. If I am dealing with dividing x to a power by x to a power, you subtract the top power minus the bottom power, a minus b. So over here, x to the 7th over x to the 4th, 7 minus 4 is 3. The next one, finding a power of a power. So for this, if I am raising x to the a to the power b, power to power, you multiply them. So x to the third raised to the sixth, 3 times 6 is 18. When we're dealing with negative exponents, so if we have a situation where we have x to the negative a, then it's going to be the reciprocal of x to the a, so 1 over x to the a. So if you have your exponent negative in your numerator, it's going to move to your denominator and the signs get switched. If I happen to have a negative down here in my denominator, I would move it to the numerator and it would become positive. Over here we have x to the negative 7th, so that's 1 over positive x to the 7th. And then here, when we are raising anything to the power of 0, we get a 1. There is one exception, and that exception is 0 to the power 0 is undefined. So these are the laws of exponents that we should understand coming into the Integrated 2 class. So now this is our new idea that we're learning, okay? And this is fractional exponents. So when we have these fractional exponents, if I have x2 1 over b, the denominator is your root. It is going to become your index. So x to the 1 over b means I'm taking the b root of x. So in this example, I have 64 to the 1/3. So it's going to be the cube root of 64, which is 4. Now, when I have that same rule, but when my exponent is not a 1, the numerator is not a 1 in my exponent. The numerator is always your power. The denominator is always your root. So you can do this two ways. You can either raise it to the power first and then root it like we did here. X to the a is then being b rooted, or you can root it first and then raise it to the power. So here we took the b root of x and then we raised that quantity to the power a. In this example below, I worked it out both ways. So here I did the power first, so I squared my 8, which was 64. Then we took the cube root, which was 4. Over here, first we took the cube root of 8, which is 2. And I personally would use this method if I was doing this without a calculator. I'd always root it first to make it smaller. Then we're raising it to the power 2, which is again a 4. So now what we're going to do here is we're going to write these in radical form. Now, I'm just going to kind of show for those of us who have not used the CAMI as much as who just joined our class, you can type math here. So if I come here to this equation, this division sign, this is equation. I'm just going to get this up so I see here's my choices, okay? I'm going to click a little text box here. And then if I want to write this, I want to write the 6th root. So here, this is my nth root, okay? So I would put my x here, and I would put my 6 here, and I could get my 6th root of x, and that would be my answer. And I'm going to do this. I'm going to fill this so you can see what I wrote, okay? Now, this one here, again, just a little reminder. I'm just going to write as a reminder here. The 2 is my power, and the 7 is my root. Okay, the top of your fraction is your power, the bottom of your fraction is your root. So again, if I get my text box, so not my text box, sorry, my equation box, I'll get that here, and I'm gonna just fill right away so you guys can, well, I guess I'll fill once I start writing. So I want the 7th root. So again, I'm gonna come and get this here. Okay, I'm just gonna move this so it's, sorry, up a little higher. Okay. So I want the x in here, and so this is going to be an x squared, and to do the square, you can either pick the square here with this caret button, or you can just do shift and the number 6, and it will automatically raise it to a power. And so I can put my 2, and then here I can put my 7. So you could write it like this. Now I could instead, if I prefer, okay, and so I'm just going to get out of my my exponent. And let me open another text box. Let me just fill real quick. Oops, did not mean to change the color. Get that to be black. Hold on, in here. Get that to be black. Then I'll do my fill. Okay, well, I did opposite, but that'll be fine for us. Okay, so I could also have instead done the 7th root first. Okay, 7th root first. So I could have done the 7th root of x, and then I could have taken all of this and raised that to the power 2. And again, to get the power, you can just do shift and 6. And here, I'm gonna do shift and 6 again, so I get it up a little higher. Okay, and there you go. And let me fill this time. Let me fill it with yellow. There you go. So these are both the same. You could have used either one of them. Okay. So I just want to kind of show those of us who haven't used it that there is that availability for you. Okay. So on the next one, just a little reminder, if it's raised to the negative power, it's going to be the reciprocal. Okay. So this is going to be 1 over x to the 3/4. So I'm going to have 1 over basically the 4th root of x to the 3rd. Okay. And I'm going to just do this one more time. And then I'm going to start just doing it with just writing, because that's how I usually do it. But let me just get my text box. So if you need a fraction, you can do a fraction. Just hit the backslash. There's a fraction choice up here, but I just like to hit the backslash. So here's the fraction choice right here, but I just hit the backslash. And then I'm going to do 1 over, and here, let me get this higher up on the screen. And I'm going to move this a little so we can see it. Okay. And then I am going to get my root, and I am going to take the 4th root of x, shift 6 to the 3rd. Okay. So you can write it like that. Okay. Now I'm just going to go to writing, because that's usually how I personally do this. And here, let me just fill this in. Sorry. Let me get the fill. One more time. Okay. And I can move this. Okay. Now I could have instead, if I prefer, I could have done it 1 over, and then I could have taken the 4th root of x and then raised that to the power 3. If I am writing this out, I personally will do it like this. If I'm computing it, I would compute it like this. Okay. Okay. So on this one, 1.2, I'm going to change that to a fraction. This is actually 6/5. So what does that mean? I am going to take the 5th root of x to the 6th. That's how I personally would write it if they're just asking me to write it. Or you could be taking the 5th root of x first and then raising that to the power 6. That is the same. Now on the next section here, we're going to write it in exponential form. So what this is going to be, my x is being raised to no power, so it's really the power 1. Okay, there's no power in there besides 1, so it's really a 1/4. So that's x to the 1/4. On number 6, when I'm doing this one, this is going to be x to the 2/5. Number 7, I am going to take x. The 4 is going to be my numerator. The 5, whoops, I need to change the color. The 5 is going to be my denominator. So it's x to the 4/5. Over here, that 8 is an 8. Has nothing to do with anything else. Now the y is going to be y to the 3/2. So the y is being cubed, so that's why I have the power 3, the 3 in the numerator, and then the square root is an index of 2, so it's 3/2. Now the next section here, they want us to evaluate, and they want us to evaluate this without a calculator, okay? So if I'm evaluating without a calculator, I am probably going to want to do the root first, okay? The root first when I'm doing this, okay? So if I'm going to do this, I am going to take the 5th root of 32. Then I'm going to raise that to the power 3. So the 5th root of 32 is 2. And then 2 to the 3rd is 8, and that's your answer. Now, when I'm doing the next one, same idea. Again, I'm going to start with the root because it makes it smaller. So I'm going to take the 5th root of a negative 32. And you might say, hey, I can't take the root of a negative. You can take an odd root of any number, positive or negative, because a negative times a negative times a negative, where you have an odd amount of them, is always negative. So if I have 5 of them, it's still going to be negative. So the 5th root of a negative 32 is doable. Then I'm going to take that and I'm going to raise that to the power 3. Okay. And so when I take the 5th root of negative 32, I get a negative 2. And then I'm going to raise that to the power 3, and I'm going to get a negative 8 as my answer. Okay, on this one, when I'm doing this, you can think about this as this is going to be 1 over 81 to the 1/4 first off, okay, because of that negative exponent. And then what I'm doing is I'm going to take the 4th root of 81. Let me write that 4 in front, a little smaller. So you want to be careful when you're writing your index that you don't make it look like a number multiplying in front. So I'm taking the 4th root of 81, and the 4th root of 81 is 3. So this is 1/3. On number 12, okay, I'm taking 4 to the 1.5. So instead of thinking of it as a 1.5, it is a 3/2. So again, I'm first going to root it. So I'm going to take the square root. I'm putting the 2 there just to emphasize. You don't need to put the 2 there, okay? Because if you don't have a number there, we know it's a square root. Then I'm raising it to the power 3. So the square root of 4 is 2, and then 2 to the 3rd is 8. On number 13, so the negative is going to flip this, so it's going to be 1 over a negative 27 to the positive 4/3, okay? And then I'm going to start by doing my cube root first. So again, I'm going to focus on doing the cube root first. That's what I'm going to focus on. Okay. So when I'm doing that, I am going to have 1 over the cube root of negative 27. And then I'm going to be raising that to the power 4. And the cube root of a negative 27 is a negative 3. So this is going to be 1 over a negative 3. And that's going to be raised to the power 4. And negative 3 to the 4th is 81. So this is going to be 1 over 81. And that's your answer. Okay, so here we're going to be using laws of exponents and we're going to be simplifying them. Okay, so here, since these are the same base, I'm going to add my exponents. So this is going to be x, and let me do this first. Let me first get a common denominator. So this is going to be x to the 6/9. I'm going to be timesing top and bottom of that by 3. And now I'm going to add my exponents. So this is going to be x to the 10/9, and that's going to be my answer. Now, if they wanted us to rewrite it, okay, they didn't ask us to, but if they did, I would have taken the 9th root of x to the 10. But it's fine to leave it in exponential form here when they're asking us to simplify using laws of exponents. Okay, so this one here, next one. Again, I'm going to get a common denominator. So this 3/5 is going to be a 6/10 divided by x to the 1/10. And when I'm dividing, I'm going to subtract the exponents. So I'm going to get 5/10, which is x to the 1/2. Now, x to the 1/2, just a reminder, is just the square root of x. So on number 16, power to power, I multiply. And so when I multiply a 4 and a 4/7, so I'm going to be doing 4/7. I'm going to write that better. 4/7 times 7. What happens is my 7s are going to cancel out, okay? And I'm going to end up getting x to the 4th. And that's your answer. So when I'm taking the 7th root of something, 7th power undoes it, okay? But the 4th power is not undone. There's nothing happening to that. Okay, over here, I'm going to raise everything to the 1/3, okay? So what that means is when I'm doing this, I'm really doing the cube root of a negative 27. I'm just going to write that so we know what that means. For my x, it's going to be power to power, so I'm going to multiply and I get a negative 3. For my y, power to power, I multiply, I get a 2. Okay, so now I'm going to clean this up a little bit. So for my 3 to the cube root of negative 27, that's going to be a negative 3. I am going to have my y squared still be on the top, and this x to the negative, let me get a different color. This x to the negative 3rd, oops, I wanted to get it a different color. This x to the negative 3rd is going to move to the bottom. And that's your answer. And that negative 3, that is a normal number. Do not move that to the denominator. Okay, and that is the notes. So hopefully you found that helpful. And I will also put a copy of this so you guys have the copy, but I wanted to explain it.